So hello guys, I'm Cornelius. Today I'm going to take you through electrical joints, uh, types of cable joints. Uh, so we are going to begin with the requirements for the joints given by the IEE, which are two. The first one is accessibility, and the second one is soundness. So for accessibility, we say that all joints shall be readily accessible. Thus, joints of any type must not be pulled into conduit tubing or hidden in partitions, but must be enclosed in conveniently placed inspection type joint boxes. So about soundness, we say that a joint which is mechanically sound must not pull out under normal strains to which it may be subjected to during installation or in its working life. So uh, to be electrically sound, a joint must have the following: low resistance and no overheating when carrying current. So let's go to the qualities of a good joint. Uh, so the first quality of a good joint is that it must retain conductivity of the conductor. It must withstand maximum fault current. It should provide trouble-free long life. It must have low resistance as an equal length of the conductor itself. It must retain the mechanical strength of the conductor on which it is made. So we are going to the types of joints, and we are going to begin with the Britannia joint. So for Britannia joint, we say that it is used for single overhead copper wires which are in considerable tension when in use. Each of the wires to be joined are thoroughly cleaned and tinned for a distance of 75 millimeters. About 6 millimeters of the end of the cable is bent over at right angles. The two wires are then brought together over a distance of 50 millimeters with the stops in the opposite direction and held in a vise or pliers. They are then bound closely and tightly with suitable binding wire. The binding is carried past the stop at each end to 4 or 5 turns. The whole joint is then soldered. So this is how the Britannia joint looks like. So we are going to the second type of joint, that is the scarf joint. For the scarf joint, we see that it is suitable for wires which are not required to stand tensile stress, and when the joint is to be as small as possible. Each of the two ends is chamfered by filling over a distance of about that 5 millimeters. The ends are cleaned and tinned and fitted together so as to have the same diameter as an end-cut wire. They are then held together tightly and wound with a binding wire over uh, over 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 so over a distance of 60 millimeters. And so this is how the stop joint is. So let's go to the third type of joint, that is the T-joint. So the through wire is barred, cleaned, and tinned for a distance of 50 millimeters. The T wire is similarly prepared, and 50 millimeters of its length is tightly bound round the through wire, such that the joint leaving 3 to 4 turns and soldered to allow for flexibility when insulating. So this is the presentation of the T-joint, how it is. So let's go to the fourth type of joint, That is the married joint. So for the married joint is very strong when properly made. At the ends of the wire, 75 millimeters is stripped of insulation, the strands of which end are firmly twisted together in the direction of the lay of 25 millimeters, leaving 50 millimeters splayed out. The wires are then brought together end to end, each strand laying between two strands of the opposite cable. And you can see the presentation of the married joint. So let's go to the fifth type of joint, that is the straight twist joint. And you see that each end is prepared, cleaned, and tinned over a distance of 75 millimeters. The wires are laid together about 50 millimeters from the ends and twisted tightly round each other in opposite directions. The joint is then soldered from end to end, and you can see the diagram of the straight twist joint given below. And that is the end of the presentation. Thank you guys for watching.